Computer Programming A lecture around variables. So initially we framed our understanding around flipbooks. That's what we're trying to make the code do. We're making it draw the canvas over and over. It's never good when Okay, so back over here. So we're focusing on this part, declaring, initializing, and modifying. The first two steps of using variables should be familiar like in math class. You say x exists, then you give x a number, let's say it's 200. And the newest part that takes the most time is this part here, because it's different than what's in math. X is on both sides, and if you solve for x, you get 0 equals 1. You're like, why, Mr. Chan? Because programming, this is the updating. This is the modifying step. This is the part that changes your image. This is the line that allows it to move. And yeah. We'll take a step back. Before talking about variables, we want to highlight, like in the star example, you can put operations like math symbols into a function, into like ellipse, and it'll do some calculations for you. One example of that is using them as arguments. So the numbers that you place in. So this one generates like what, 22, 100. The width is 200, and then this one should be 240 or something like that. Why is this useful? You can implement symmetry quite easily. If we notice in red, it has minus 75 and we want it across on the y-axis, so you add in 75 and suddenly you have like this mirror image of an ellipse. Maybe you have mirror image of like a circle and it moves slightly. Expressions are quite useful. It's even more useful when you use it with a variable. And so here's the new part. Instead of like in your shape patterns assignments when you're drawing animals, drawing national flags, you're always typing numbers. And you might have found it tedious, especially if you have lots of parts to your animal, a lot of circles and ellipses and rectangles and lines and shapes, that you notice you have to make that change, like the same kind of change in a bunch of different places. So that's why we have variables there. We can declare it like we do here, var num, and now we can use this variable to store some values. Mr. Simon always says that it's like a mailbox. We say the mailbox exists, and now the mailbox will contain something. Right now, I have like an empty mailbox. Var num doesn't have any number in it, but it does exist. Var is the name, and the new keyword you're introduced, you'll also see this in your GameLab blocks, is the var block. I think it defaults to X in GameLab. Okay, so here's the part that's the next step. Once you've declared it, like I have up here, the next line is called initializing, and that uses our good old friend, the equal sign. It has a fancy name in computer science. It's called the assignment operator. This is what gives num the value of 5. We've just initialized it. We've given it its first value to be 5. And now num, wherever you see 5, you can replace it with num, and it'll work largely the same way. Computer scientists are really lazy people like mathematicians, and so we can do both of these lines at once. Var num equals 5 creates a variable called num, and it sets it equal to 5, all in one step. You will see these vocabulary words, declaring and initializing, or to initialize and to declare, on your quiz. Okay. So a bit more about that first idea, using math operators, now using your variables. Now you can do something like this. Wherever values or whatever variables you declared and initialized, you can use it in your expressions, in your functions. So now 50 is going to be added on to 17. Its x-coordinate is now at 67. And now the y-coordinate for here is decreased by 13 pixels, whatever that is, 37. And let's say, like, if we had a bunch of these ellipses and in all different places, now we can easily just do one change, and now all those other variables have now been updated. Now, since I went from like 17 to 18, I don't have to go in and change all those x-coordinates and increase it all by 1. Variables are useful in that way. A little bit about the spelling or the syntax of this assignment operator. It doesn't work like it does in math. Down here, 5 equals num doesn't work in computer programming, but it does make sense in math. So be careful here. The right-hand side is special compared to the left-hand side. On the left side, you have the name of your variable, and on the right side, you have the value you want to store there. So I should have drawn a little arrow that has 5 pointing to num. The opposite is true, or if you try to do it the other way around, and let's say num already exists, 5 already has a value, so you can't put like an unknown thing into a 5. This will be assessed on your quiz, like the very similar question. Order matters here. Num equals 5 is legal, 5 equals num, can't do that. It's going to spit out like an error of some sort. So, other things that are tricky is that you can't do initializing an assignment as an argument. Look at this line. It says ellipse int x or var x equals 45. That's illegal. We can't quite do that. Although computer scientists are lazy, this is putting like 3 steps into one. That's doing way too much. You can do x plus 45 here. That would be okay. But declaring and initializing has to happen outside. So something more appropriate would be splitting that line. Var x equals 45. And so down here, you have the x-coordinate be at 45. That's okay. And as I was saying before, here's the newest, hardest part. The green shows up kind of badly, but x equals x plus 1. When we look at this line, computer scientists are thinking, okay, whatever was the old value of x, increase it by 1. So what's 3 plus 1? Yeah. So now you've updated x to be the value of 4. That's what's going on here. We skip over, I want a better example. So let's just jump down here to the practice quiz question. If you have x and y being assumed they are declared like this, which picture, there's a very subtle difference here, matches the code on the left? The top picture or the bottom picture, you can refer to it as the red and the purple. Give you a couple seconds to think. 50-50 chance. Maybe you have your answer, and now I will review it. So at this point, I would write on the whiteboard, but instead I want to make it useful. Let's say if you want to review it, so I'm going to be typing in here, and my changes will be in red. As I'm thinking about this program, okay, I see x, I see y. Great, they're 50. So I would put in 50 and 50 temporarily for these numbers. It's like substitution in math. And where's this circle being drawn? 50 and 50. That should be like over 50 here, 50 down here. Looks like this circle's good. Looks like this circle's good. And now we go down here. Okay, 50 was my initial value of x, and now it's being updated. What's on the left-hand side now? You're thinking, okay, 50 plus 50 equals 100. And it looks funny right now, but now x has been updated. So what's x's value down here? Is it 50 or should it be 100? Correct answer here is 100. Has y changed at all? Nope. So 50 goes there. We bold this as these are my changes for the purposes of the video. And then you think about, okay, my second circle, it's drawn over 100 pixels on the x, so it should be covering it up. This one is below, so the order's off, so it has to be the red one. and thus we'll emphasize, so if I were taking a test, I would already pick red, and I'm convinced, but for your learning, I will replace these numbers down here to show you that updating happening. Now x down here becomes 150, and we get that third and final circle at 150 for x, and y has never changed, so it remains that value of 50. So far, so good? Questions? Okay, so now I have to pull up a code, or like a CodePen example. The one tricky thing right now is, okay, great, Mr. Chan, you can draw shapes more easily, but where's my animation part that I was promised of this unit? And it's like, great question, great wondering you have quietly in your heads. So I'm pulling up that old program. Let's pick up this one. Is this one what I want? Yeah, something like this. So your starter code is like this circle down here. Notice how it moves and then it resets. We just focus on having it go down the screen. That's very similar to the starter code you had. In fact, why don't... So the line that makes it go down is updating the... Oh, this is confusing. So we highlight this line right here. I'll make it larger. This is the line that controls the falling motion, so you're changing the y. How so? Remember, the y-coordinate starts at 0 up here, and then it goes down the screen, being its maximum value down here. Different than in math class. 0, and let's say that's the height. So this line of code, we look up x falling and y falling. Where does that start? It starts at 0 and 0. Cool. We look down to wherever y falling is being used. Now it's down here. Y falling equals y falling plus 1. So now it increases and falls down the screen. But hold on, how is it changing? Then we emphasize like what's actually happening with the draw function. When you were drawing your animals, they were always in the same spot. Little did you know that your animals were actually being drawn like a billion amount of times, all on top of one another. And so because the coordinates didn't change, it didn't move. And if I comment out this background line, you'll see. Now that when I update it, it leaves down a trail. Right now it doesn't look like an animation because it's still the same page, and we don't see that, we see what came before. So now it just looks like a little, worm crawling across the screen. And if you look very subtly, you see that circle slowly moving. That's the purpose of getting that new page. Otherwise, flipping to a new canvas, draw a background. And when you put those two together, the repetition of the draw loop, or the draw function, and variables, you get a simple animation. Questions? Comments?